Hello everyone! Today, we're diving into the fascinating world of numbers, specifically how to work with very large and very small numbers. Whether you're dealing with astronomical distances or microscopic measurements, understanding how to manipulate these numbers is crucial. Let's explore the techniques and strategies that make this possible. Before we jump into working with very large and very small numbers, it is important to revisit a fundamental concept: the power of 10. The power of 10 is a way to express numbers that are either extremely large or extremely small in a more manageable form. For example, 10 cubed means 10 multiplied by itself 3 times, which equals 1000. Similarly, 10 to the power of -3 represents 1 divided by 10 3 times, giving us 0.001. This method helps us easily handle and simplify calculations with numbers that are either very big or very tiny. Now, let's learn how to write any number in scientific notation. Scientific notation expresses a number in the form of a times 10 to the power of k, where a is a number greater than or equal to 1 and less than 10, and k is an integer that tells us how many times to multiply or divide by 10. For example, if we have the number 1200, we can write it as 1.200 times 10 to the power of 3. Of course, we can write 1.2 times 10 to the power of 3 instead. Here, a equals 1.2, which is between 1 and 10, and k equals 3 because 1200 is 12 multiplied by 10 3 times. Let's look at two similar examples to solidify our understanding. I encourage you to pause the video and try converting these numbers into scientific notation yourself before I reveal the answers. On the other hand, for a very small number like 0.1234, we can write it as 1.234 times 10 to the power of -1. In this case, a equals 1.230 for k equals -1 because 0.1234 is 1.234 divided by 10 1 times. Let's work with 0.0234. Pause the video and try converting this number into scientific notation. 0.0234 can be written as 2.34 times -2. Remember, the decimal point moves 2 places to the right to get 2.34, so the exponent is -2. Last example is 0.0034. Pause the video and try converting this number into scientific notation. 0.034 can be written as 3.4 times -3. Now, let's talk about how to read scientific notation on a calculator. Calculators often display scientific notation in a compact form, using e to represent times 10 to the power of. If you see something like 1.2e30 on your calculator, the e stands for exponent, indicating that the number following it is the power of 10. So in this case, the number 1.2 multiplied by 10 raised to the power of 30, which is a very large number. Let's work with 3e10 as second example. Pause the video and try converting this number into scientific notation. Just like before, the e stands for exponent, so 3e10 represents the number 3 multiplied by 10 raised to the power of 10. If you see something like 4.5e-10 on your calculator, the e still stands for exponent, but this time, the negative sign indicates that the number is very small. This number represents the number 4.5 multiplied by 10 raised to the power of -10. Let's work with 5e-15 as second example. Pause the video and try converting this number into scientific notation. Again, the e stands for exponent, and the negative sign before the 15 indicates that this number is very small. So 5e-15 represents 5 multiplied by 10 raised to the power of -15, which is an extremely small number. Thank you so much for watching and listening. I hope this video has helped you understand how to work with large and small numbers using scientific notation. Keep practicing, and you will master these concepts in no time.